All right, lesson 5.4 is our last video in our data unit. It has to do with scatter plots and regression. We're going to begin by going over some vocabulary. So first off, a scatter plot is just a set of data graphed as ordered pairs in a coordinate plane. So as long as all of your data has two variables connected with it, you can plot it out on the graph. It'll just put a bunch of points out there showing all of your data, and that would be a scatter plot. A line of best fit would be a line that closely approximates the set of data. So again, with all the points all over the graph, a line that is, as close to all of those dots as it possibly can be. Correlation measures the direction and strength of the linear relationship between two variables. It measures between -1 and 1. Now, if it's a -1, that means it's going to be going downward. So it has kind of a negative slope. If it's +1, it has a positive slope. Now also, the closer the correlation is to 1 or -1, the stronger the correlation is. So it means the points are really, really close to each other. If it's like a correlation of 0, that means all of the points are scattered everywhere and there really is no correlation. Causation then. The belief that a change in the response, so the dependent variable, y, was caused by a change in the explanatory or independent variable x. So causation means you believe or you think that if the variable x changes, it causes y to change. So sometimes in our data we can see that, oh, every time that the x variable goes up, the y variable also goes up. Well, sometimes that x didn't cause y to go up, they just happen to both go up. So causation and correlation are definitely going to be different, and we'll look at that towards the end of our lesson. Regression. Regression is the study of how a response, or the dependent variable, y, changes as an explanatory, or the independent variable, x changes. So regression is just basically, again, we're looking at how whenever x changes, it affects y. Bivariate. Bi meaning two, variate meaning variable. So it's the analysis of a relationship between two variables. So bivariate, or on your calculator sometimes you'll see 2 VAR, two variables. You'd be looking for a bivariate relationship between two of your variables changing, normally an x and a y. So let's look into scatter plots now. Scatter plots are used to graph two sets of data as ordered pairs in a coordinate plane. Scatterplot can help show whether there is a relationship or correlation between the data sets. So as an example, here we have a picture of a table over here with all of our data, and you can see the scatter plot over here on our x and y axes. They are labeled, and we have a bunch of data points. So the story goes, we're looking at baseball. The table below shows the number of home runs and runs batted in for various baseball players who won the Most Valuable Player award during the 1990s. So we need to make a scatter plot of the data. Well, they didn't give us the name of each player, but we have a list of how many home runs each person hit, and to go along with the home runs that they hit, also the runs batted in, or the RBIs. So if this person hit 33 home runs, they also happen to hit 114 RBIs. This person down here happened to hit 41 home runs and 128 runs batted in. So all we had to do then, home runs on the x-axis, runs batted in on the y-axis, we would just plot. We go over, looks like this one should be our 28, and up to 61. So this data point right here has to do with this set of data. Now all of these data points will go with one of these people. So this is just a scatter plot. We're just showing all of the data plotted out on this graph. For another example, the table over here shows us the number of women serving in the United States Congress during the years 1987 through 1999. We need to make a scatter plot of this data on the graph below. Now, notice this little squiggly line here, it means we're cut off. We're not necessarily starting right at 0. This line is 100. This would be 101, 102, 103, 104, 105, 106. So depending on the session of Congress that we are in, this is the number of women that we have. So it's not perfectly scaled, and we went over that before, how sometimes when it's not perfectly scaled, it can throw things off. But let's go ahead and just make our scatter plot, and we'll see how this actually turns out. So, Congressional Session 100, there were 25 women. So we go to 100, and about here is 25. At 101, there were about 31, so somewhere about there. 102 is a little bit more, 33. At 103, we were at 55, so almost the 56 there. At 104, we were at 58, just a little bit above 56. And at 105, we were at 62, so somewhere in between these ones. So here are our different plots, our different dots, our data points plotted out. You can almost kind of see how they make a line as they go up. So it looks like these ones do have some correlation. Because they are all so close and it looks like they almost make a line, you would say there is definitely a positive correlation between these two sets of data. Predicting equations, or making the line of best fit, it's also called a regression line. When data is put into a scatter plot, they may seem to form a line or a path on the graph. The correlation coefficient is used to measure how well the data lie on the straight line, or the line of best fit. The equation of the line of best fit, or you can call it the regression line, can be used to predict one of the variables given the other variable. So here's an example, finding and using the prediction line, or we call it the line of best fit. This is finding it out by hand. So for example, storage costs. According to a certain prediction equation, the cost of 200 square feet of storage is $60. The cost of 325 square feet of storage is $160. So if we want to find the slope of the prediction equation and then figure out what it represents. So since the cost depends on the square footage, we're going to let X represent the amount of storage space in square feet, and Y represent the cost in dollars. That means the slope, again going back to linear equations, we can find slope by using the formula m equals y2 minus y1 over x2 minus x1. So this should be familiar from our linear equations unit. So using what we've got here, our y2 was this 160. That's how much the second one cost. Our y1 was 60. That's how much the first one cost. Over, we're going to look at our square footage. Square footage of the second one was 325. Square footage of the first one was 200. So 160 minus 60 is 100. 325 minus 200 is 125. So 100 over 125. We would say that our m, the slope there, is about 0.8, 0.8. So the slope of our prediction equation is 0.8, which in this scenario, or this case, because up here it's dollars and this is feet, we would say that the price of the storage increases by $0.8 per square foot. Or, instead of calling it $0.8, you can call it 80 cents for each 1 square foot that increases in the storage space. So we just looked at how to find the m, or the slope. Let's look at how to find the whole equation. Using the slope and one of the points on your line, you can use the point-slope form to find a prediction equation. So again, back to our linear equations unit here, y minus y1 equals m times this whole amount, x minus x1. This is the point-slope form of the equation. So we're going to use x1 and y1 as our 260. We're going to use our m, was that 0.8, that was our slope. So we just plug everything in. We get y minus 60 equals 0.8 times all of this, the x minus 200. But we're going to distribute that 0.8 to both of these, so 0.8x minus 160. Now we're going to add 60 to both sides to get rid of that, and we'd have y equals 0.8x minus 100. So this is our prediction line. This is going to be the line of best fit if we were to look back, and in this situation, it should fit that line. So, for example, we're going to use this set of data to make our own scatter plot and line of best fit. First off, we're going to need to plot these points. So 1, 1 would be about right here. 3, 5, we'd go over 3 and up to 5. 4, 7, we'd be over at 4, up to about 7. Over to 6, up to 11. Over to 7, up to 12. Over to 8, up to 15. And we need to find out what we think we would be at if we had 10. So here's 8, here's 9. We want to know where we'd be at. It should be somewhere around here, but we don't know exactly for sure. Well, notice that these points seem to lie in a straight line. And that line looks about something like that. Now notice that not all these points are exactly on that line, but they look pretty darn close. And it looks like this line seems to go through this 1, 1 and the 8, 15. So let's use those as our two spots, 1, 1 and 8, 15. Those are two data points that it looks like it's going to go through for sure. We'll use those to find our slope then. So we take 15 minus 1, that's our y2 minus y1, over 8 minus 1, x2 minus x1. We would have 14 over 7, which is the same as 2. So our slope is 2 in this case. Now, for our slope, point slope form of the equation, it'd be y minus y1 equals m times x minus x1. Our m is 2, so that's going to get plugged in right here. Just cross that out and call it 2. We're going to use this nice and simple 1, 1. So the y1 was 1, x1 was 1. So let's clear all that up. It looks something like this. Y minus 1 equals 2 times x minus 1. Distribute this 2, and we'd get y minus 1 equals 2x minus 2. Add the 1 to both sides, and we'd get y equals 2x minus 1. So this would be our line of best fit. Y equals 2x minus 1. Now if we wanted to know where we should be at, if we had 10, we would plug 10 in right here. So we'd have y equals 2 times 10 is 20, and then minus 1. Well, 20 minus 1 would come out to 19. Now if we look at this, as this keeps going up, 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 it's 10 about right there. This should be about at 19. This was 12, 15, this line should be 18, and it's a little bit above that. So it looks like we should be about right around 19 there. So this next one, we're going to be looking at using technology to find our scatter plots. We will do that in our next video.